Hello students, welcome to this video lecture. Here we are going to discuss some CBSE pattern questions, and those questions are of the chapter number systems. So let us see. The first question is of 1 mark. It says state whether the following statements are true or false and justify your answers. First is every irrational number is a real number. So this is a true statement because irrational number and rational number together form the set of real numbers. So every irrational number is a real number. This is true. Every point on the number line is of the form root over m, where m is a natural number. This is not true because if we suppose we are taking a number 6.57, can we write it in the form root over m, where m is a natural number? It says every point on the number line is of the form root over m, where m is a natural number. I have taken a point 6.57. I am saying that it is of the form root over m. So that means 6.57 square should be equal to m. And what is m? It is a natural number according to this statement. But is 6.57 square a natural number? No, it is not a natural number. It will be some number which is a rational number but not a natural number. So this statement is false. Come to the third statement. Every real number is an irrational number. It is wrong. A real number may be an irrational number or may be a rational number. So we cannot say that every real number is an irrational number. Instead, we can say every irrational number is a real number. So this was a 1 mark question of true and false. Let us see another question which is also of 1 mark. State whether the following statements are true or false. Give reasons for your answers. Every natural number is a whole number, of course, because whole number has natural number and 0. 0 is an extra term. So every natural number is a whole number also. This is correct. Every integer is a whole number is not correct, because those integers which are negative are not whole number. Whole number are only positive integers and 0. So this is a wrong statement. Every irrational number is a whole number. No, every rational number is not a whole number. Let us take 2 by 3. Is this a rational number? Yes, this is a rational number. Is it a whole number? No, it is not a whole number. So we will say this is wrong. So we have second question. Now we have the third question. Show that 3.142678 is a rational number. In other words, express 3.142678 in the form p upon q, where p and q are integers and q not equal to 0. So we can write 3.142678 3.142678 as 3142678 upon 10000000. We remove decimal and put those many zeros in the denominator. Now we will divide by a common term and we get a form p by q, and we can leave it as it is also, because this can always give us a reduced term. Okay. So we can reduce it. Of course, both are the integers and q is not equal to 0. Further, the common factor we can reduce it to the simplest form. So it is a rational number. Let us come to the fourth question, and the marks allotted to fourth question is 2 marks. Find 5 rational numbers between 3 by 5 and 4 by 5. How do we do it? 3 by 5 is here and 4 by 5 is here. First rational number will be just in between, which can be written as 3 by 5 plus 4 by 5 upon 2, which will become 7 by 10. So the first natural number is first rational number between 3 by 5 and 4 by 5 is 7 by 10. Next, let us take this one. We have to find 5 rational numbers. So this is actually average of 3 by 5 and 7 by 10. So 3 by 5 plus 7 by 10 by 2. What this will give? This will become 6 plus 7, 13 by 20. And let us take a point here in between these two numbers. So 7 by 10 plus 4 by 5 upon 2. This will become 8 plus 7, 15 by 20 students, right. Now there we have got 3, 1, 2, 3. Let us find 2 more. So, I am taking this one. So, this one is between 3 by 5 and 13 by 20. So, 3 by 5 plus 13 by 20 and half of this will be equal to 4, 3, 12, 12 plus 13, 25, 25 by 40. That can also be written as 5, 5, 25, 5, 8, 45 by 8 students. Let us take a point here also. So, this will be 15 by 20 plus 4 by 5 upon 2, the average value. So, this will become 16 plus 15, that will become 16 plus 15 will be 31, 31 by 40. So, right now we have 5 rational numbers which lie between 3 by 5 and 4 by 5, those are 13 by 20, and we have 5 by 8, and we have 7 by 10, and we have 15 by 20, and we have 31 by 20 students. So, these are the 5 rational numbers which we possess right now. Okay. Now, let us come to the next question. Next question is again of 2 marks, 4 to 7 are of 2 marks. Show that 1.27, 27, 27 so on, which can be written as 1.27 bar, that is 27 is repeating for indefinite time, can be expressed in the form p by q, where p and q are integers and q not equal to 0. So, let us see how can we express this. Let us suppose 1.27 bar is equal to x, x is a rational number. So, we can do 100x here, this will become 127.27 bar, because it is never ending. Then we will say, let us subtract from here to here. So, 100x minus x, and from this if we will subtract this 0.27 bar will cancel, 127 minus 1 is 126 students. So, we have subtracted equation 1 from equation 2. So, 2 minus 1 is this. This implies 99x is equal to 126. So, what is x students? 126 by 99. Can we divide it by common factor? We take 9, 9 11 is 99. We take 9 here. So, 9 1 9, 9 4 36. So, 14 by 11 is the number. So, we can express 1.27 bar as 14 by 11 students. Okay. Let us come to the next question, which is of 2 marks again, and it is 6th question. Rationalize the denominator of 1 by 2 plus root 3. So, right now it is irrational, denominator is irrational. What we do in such situation? You remember, we multiply by 2 minus root 3 in the numerator, and we multiply by 2 minus root 3 in the denominator. So, in numerator becomes 2 minus root 3 and denominator becomes 2 into 2 4 minus root 3 into root 3 3, that is a square minus b square formula. So, this will become 2 minus root 3 upon 1. So, this is what we say, that this number is equal to this number, where we have rationalized the denominator. Now, let us come to the next question. That question is of last of 2 marks. Visualize 4.26 bar on the number line up to 4 decimal places. You remember how we do this? Process of successive magnification. So, 4.2626 up to 4 decimal places is written like this. We take number line, we find 4 somewhere and 5 somewhere, we divide it into 10 parts, 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 10 equal parts. 4.2 is here, 4.3 is here. We will magnify this part and we will write on this number line, this is 4.2, and here we will write this is 4.3. Now, this is 4.26. We will again divide it in 10 equal parts. Let us take this one as 4.3. These are 10 equal parts. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4.26 we need. So, 1, 2, 3, 4, 5, 6 is here and 7 is here. This number is between 4.26 and 4.27. So, we will enlarge this and we will plot 4.26 here and 4.27 here. Now we will divide it into 10 parts, and then we have 4.262. So 4.262 is here and 4.263 is here. This is in between both of them. So we will magnify this again on the number line. This is 4.262, this is 4.263, divide into 10 equal parts. Now we have 2.2626. So 1, 2, 3, 4, 5, 6. This point finally is 4.2626 students. So we keep on using successive magnification of that portion of the line, and we finally find that 4.2626 is lying actually here. So we had to magnify it how many times? 4 times, students, in order to find the value. Now let us come to the next question. This is of 4 marks. It says, look at several examples of rational numbers in the form p by q, where q not equal to 0, where p and q are integers with no common factors other than 1 and having terminating decimal representations or expansions. Can you guess what property q must have? So what it is saying, that there are 2 types of rational numbers, one which terminate, one which don't terminate but keep repeating. Here we are talking about those rational numbers which terminate. So if we consider all such rational numbers, suppose 263 terminates. When we write it in decimal form, this becomes 263 by 100. Let us take 215 and let us take a point here. Since it terminates, we can write 215 by 10. We can take 193201. Let us take a decimal here. This can be written as 19201 upon 1000. So what do you observe here? That any number decimal expansion which terminates can be written in rational form like this. Either we put 100 or 10 or 1000 or 10,000, depending how many places after decimal it is taking. It is taking 2 decimal places, so 100, 1 decimal place, so 10, 3 decimal place, 2000. Further, what is 100 made up of? 5 and 2, 5 square into 2 square. What is 10 made up of? That is 5 into 2. What is 1000 made up of? That is 5 cube into 2 cube. So any number which is a multiple of 10 actually is made up of 5 and 2. If we simplify this to get a common factor 1, for example, this cannot be further simplified. This can be simplified and written as 5 420, 5 315 upon 2. Now this is the simplified form. If we want this, this cannot be simplified. So in any case, the denominator after simplification is having 5 or 2. It may have none of them also, but it cannot have any other prime number. So what is our conclusion is that after simplifying, we get q in the form 2 to the power m into 5 to the power n, where m and n are whole numbers. If it is 0, so it will be 1, otherwise it is a multiple of 2. So after simplification, we find that the denominator is a product of powers of 2 prime numbers, which are 2 and 5. That is what they were asking here. So this is a theory also which we will study in the later class. Here it is as a question for us. Let us take another question. Represent root over 9.3 on the number line. Do we remember this form? Yes. How do we do that? First let us plot 0 and 9.3 here. Next what do? We take one distance here, 10.3, at a one distance more. We take the midpoint of these two. So we take a midpoint of these two, that will be somewhere here, suppose that is actually 5.15. So this is 5.15. We make a circle, semicircle with this center and this radius, keeping this as the radius 5.15. Next we take a perpendicular on this line passing through 9.3. This intersects the circle here. This is the point P. Now what we do, we join this 5.515 with P. So what we observe that this length actually is nothing but root over 9.3 students, this length actually. Why do we remember that? If you see that this hypotenuse is actually 5.15. So square of 5.15 minus this distance. What is this distance, students? 9.3 minus 5.15 is 4.15. So 4.15 square. And let us take under root in order to find this perpendicular, that is we are applying Pythagoras theorem. So this will become a square minus b square as a minus b, which is 1, a plus b, which is 9.3. So this is finally root over 9.3. In general, we can apply for any number when we find the square root of any number, students. So this is how we find root over 9.3. Let us see next question. Find these values in simplified form, of course. So 9 to the power 3 by 2. What is 9 to the power 1 by 2? First let us write it like this. 9 to the power 1 by 2 to the power 3. 9 to the power 1 by 2 is actually 3, square root of 9, and cube of that is going to be 27. So this is the answer. What about 32 to the power 2 by 5? We can write it as 32 to the power 2 and fifth root of that. Or we can also do 32 fifth root and square of that. Any one we can take first. So what is fifth root of 32? That is 2. As 2 to the power 5 is 32. Or we can say 2 to the power 5 into, we can write it like this, 2 to the power 5 is 32 into 1 by 5 and whole square. So this 5 cancels and 2 square is going to be 4. This will be your answer. This will become 16 to the power 1 by 4 to the power 3. So what is 16? This is 2 to the power 4 and into 1 by 4 is given as a power and cube of this. You can cancel 4, so comes out 2 cube. What is 2 cube? That will be 8 answer. Let us see 125 to the power minus 1 by 3. First thing, let us absorb minus. So this term will go in the reciprocal. 125 to the power 1 by 3. This is what it will become. As we are absorbing minus, so this term will go in the reciprocal. Then we will say that 125 is actually 5 to the power 1 by 3 and there is a cube, this is 5 to the power 3 125 and there is a cube root outside. We can write it like this. Now this cube root and cube will cancel, this will become 1 by 5, students. So final answer for this is 1 by 5. So this is how we can solve these given questions which are in the form of exponents and get the answer. That is all for this lecture, students. Thank you, class.